Okay, so you've already seen the slide, but there's others to come. Okay, how many of you are familiar with an S-curve? 1, 2, I saw a kind of hands. Okay, great. So for those of you who are not familiar with it, we're essentially measuring some performance parameter on the y-axis relative to time on the x-axis. So we're looking at a rate of change of some performance over time. The physical limit, the asymptotic limit of this illustrative graph moving over here is hitting ceiling, some asymptote, okay? And it's typically determined based on Euclidean math and what we deal with on Earth by some physical limit, right? That doesn't have to be just sailing ships. It can be electrons, but there's some physical limit to what's possible. And so there's typically a new paradigm or invention that creates a new S-curve. So we think about this traditional S-curve, for example, with, let's use the example of hard disk drives instead of sailing ships. So for most of us, when I look around, I'm guessing we're all sort of in the same age group. So we, at some point in the early 2000s, were working on a laptop or a computer that had a physical hard disk drive, right? A spinning disk. And so I'm seeing a lot of nods. And you could hear it spin up, and you could hear how long it would take and wait for it to boot the kernel of the operating system off a hard disk drive. There's a physical limit of how fast it can rotate without breaking. As you know, if you probably remember this, hard drives used to break, so you'd lose all of your data if you didn't back it up on physical external drives or USB sticks. And ultimately, that's problematic, not just for reliance, and you can measure reliance as a performance parameter, but just generally cost because you're replacing it. But the cost, if you use that as a performance parameter, cost per megabyte, or now we think about cost per gigabyte or terabyte or go down whatever sort of storage density you want to talk about, there was some physical parameter and limit. And then we had solid state drives invented. Solid state drives, essentially, whether it was NAND flash or NOR flash, NAND flash is sort of the standard that took off. It created a new S-curve. It allowed us to rely on a fundamentally new technology in order to scale. And so this is what happens over time. This is not Moore's law, so I don't want you to confuse this with Moore's law. This is about a fundamentally new technology that creates a new paradigm to change the physical limits of what's possible. This is really what AI is doing. And it's creating new opportunities to do things that we could never do. If you look at the cost of a genome, it's dramatically dropping beyond sort of the classic, every 18 months we double the performance while declining the cost in half, right? And that would be sort of a classic Moore's law approach. This is a fundamentally new S-curve that's changing what's possible. So when we look at this sort of fundamental change, when we look at it in the context of AI, there's so many enabling conditions and consumption conditions that are required to be able to make this possible. What I'm going to do, because we're going to run out of time in this short session, is I'm going to focus on people and ethics and responsibility. Sorry, the Y popped over onto the next line there. So why don't we talk a little bit about these two? First, let's talk about people. This is an eventuality, it's an inevitability, it's the reason you're here. What I want to talk about is the experience we have in this room that shapes what the AI is going to look like. And I'm talking about micro AI. I'm not just talking about co-pilots and all these things you're going to be doing by yourself, but your influence at a micro level inside very large organizations that are going to have a massive influence in how the technology unfolds and the implications for society. So I want to move beyond just shareholder profit and sort of sticking to a Milton Friedman approach of how you maximize profit, because I think you're going to do that anyway. You all have a mandate to do that within your organizations, but think about what the implications are beyond that. Because I think there's a way of aligning stakeholders around the development of AI technologies while concurrently maximizing long-term profit with the capabilities and the new S-curve this technology introduces for all of us. So to do that, let me at least give you some context from my background. I know you have some familiarity with it because I hadn't seen that first slide, but I guess they created one with my background. I've done a few things. I've built a lot of technology companies. I won't bore you with all of this, but I will say that we're going to talk for a quick minute about Tinder. But I founded that inside my company, Hatch Labs. So I was the founder and CEO of a Delaware C Corp called Hatch Labs. It was here in New York City. I opened my West Coast office, hired a team. They were all W-2 employees. We owned and operated our own companies. IAC, which is a large conglomerate, internet conglomerate. They were an investor in Hatch Labs along with a company called Extreme Labs, which is a venture capital firm investing in our company. And so Tinder was owned by Hatch 100%. We spun it out with some additional capital. 3.5 years, we took it public, and it's been a public company since under the symbol MTCH, Match Group. I built a bunch of other companies, and most of the investments I have are being either disrupted by AI in a positive way, because they're the ones doing the disruption. They're not caught by Clay Christensen's innovator's dilemma. They're actually the one doing the disruption. It's the same thing Tinder did to the Match Group and eHarmony, et cetera, with a different S-curve and a different set of technologies. And then most of my investments are employing AI in some capacity. Some are public companies today and growing quite a bit. It has huge horizontal implications in addition to vertical implications for each of these companies that I'm looking at on the right rail that I'm involved with. Some of these companies, most of these companies have been acquired. Some are public, some are still in their growth phase. Everything that I touch in companies I interact with and what I do are fundamentally rethinking their entire stack because of AI. Again, I think you already know this because you wouldn't be here if you weren't spending time thinking about it. But I want to push you to think about now the imagination of what else is possible and then the constraints on the ethics for some of those considerations. So let's start getting into some real examples. Okay, let's talk about medical innovation. There's a company that I'm on the board of that is addressing one of the diseases of our decade. It's been something that's been so challenging over centuries for people, but it's really hitting us hard over the last, I would say, 30 years, which is Alzheimer's disease and dementia. If you think about this disease, it's probably one of the most troubling and disturbing types of disease. When you deal with a heart attack or you deal with cancer, you still ask the question of why. Like, why did this happen to me? Why did this happen to a family member? This is very different. This isn't causing death immediately. This is robbing you of who you are as a human being. It is robbing you, your family. It is beyond painful. It's almost worse than death, okay? All of the previous innovations and attempts at research to address Alzheimer's have been quite limited. Pharmaceutical companies, as you know, have motivations to, and manufacturing facilities set up with their partners to produce pills. And they're doing drug development, which, by the way, has dramatically been positively affected by innovations in AI. The current and past trajectory of what they've been focusing on with amyloid plaques, et cetera, has not prevailed. If you look at the drugs in the market, there was a recent drug approved in 2024, and then one that was Eli Lilly, and there's a previous drug approved prior to that. The efficacy of these drugs was around 27, 28%. There's plenty of published studies you can read about it. So less than 1/3 of people were actually seeing any efficacy. And then among women, it was 12% effective. Efficacy was 12%. Doctors aren't even prescribing it to women because the side effects are so large, the chronic cost is very high, and the efficacy is marginal. I would argue there's a big question of whether the FDA should have even approved that drug. And then the second drug that came out this year, same order of magnitude of efficacy, generally for the public and for women. So we have essentially put a person in space and on the moon and developed AI and have cars drive itself, and we can't solve this debilitating disease that robs us of our identity. AI allows us to fix this. Synaptica Therapeutics, which is the company I'm involved in, the two researchers out of Italy and then out of Harvard Medical School developed technology to do neurostimulation of the brain. By the way, neurostimulation has been around a long time. So if you're familiar with it, it's used for lots of different use cases in the medical field. This is not something particularly novel. The key is that they target the default mode network of the brain, and using AI, they can do that targeting with a feedback loop to determine if they're stimulating the brain in the right way. The result for Alzheimer's is over 80% efficacy. 80%. I mean, the efficacy is night and day with the drug development and the trajectory we were on. AI has unlocked this. Neurostimulation, again, was around. AI is what allowed it to develop a new S-curve. So the applications of AI, when we think about them, we tend to think about LLMs, and we tend to think about things that are picking up media attention, but there's esoteric corners of technological innovation that are fundamentally changing because of AI. By the way, the patents issued to Synaptica and what they're doing is to apply this neuromodulation and this stimulation based on tailoring of the AI models for lots of other use cases. We think there's dramatic impact of potentially even doing stuff with strokes and lots of other leading causes of death and disability. So the applications are amazing. But this stems from human ingenuity. There's a lot of peer-reviewed research on this if you want to read about it. The big study was in Brain. There's another big study that was recently published that we're going to be talking about. But I think about this a little bit differently. Again, I told you we're going to talk about people. So think about a 60 to 70-year-old parent, or think about a researcher at MIT or Stanford or Harvard or NYU that's doing amazing work but has Alzheimer's or has dementia. What work, what research, what innovations did we not see over the course of what should have been another 20 or 30 years of that individual's life because they were robbed of their capabilities? Think about that. Forget the AI application. Think about the ingenuity coming from the person that was robbed of all the systemic sources of ingenuity and innovation that applied to other problems. So the number of people that Alzheimer's affects is enormous, but I think about it, about advancing the human condition by the opportunity cost of the inventions that could have been developed. And it doesn't have to be simply a researcher. It could have been someone that played tennis and was a professional tennis player and gets Alzheimer's and can no longer be a coach to coach the next 3 worldwide sort of champions and the top-ranked USTA tennis players in the world as kids and then maybe even adults. It's the opportunity cost of what's possible that we're also missing. It's not just the application of AI to say, oh, here's an interesting use case of what can be unlocked. So let's look at another case. This is really interesting. There's another company I'm involved in called Data, Deception and Truth Analysis. It built models over a decade of longitudinal data to come up with proprietary models that can detect deception in speech and text very powerfully. Now, there's so many use cases you can imagine if you can detect deception. Yeah, Tinder is definitely one of them. But we'll get into that because there's another company I'm going to talk about that would be really interesting for. It's called Monet Analytics. I co-founded that a few years ago. So in this data that I'm showing you, it's detecting deception from their public statements in earnings calls and their 10K reports. And these are the tickers and the names of the companies where it detected deception. With really high degrees of accuracy, 88+%, very high. If you look at statistical models, that's very high. It can detect deception. It can do it longitudinally way before the incident that led to the public market event that caused the company to collapse. Think about Enron. I don't think we have FTX here. They've done it on FTX. It was all predictable. It was all visible ahead of time from all the statements that they've made in the public media. And if you look at the private decks when they were privately fundraising, it was all there. We didn't give you the actual scores. This is all published on their website. So the commentary, if you go to Data, it's actually there. And so I pulled it directly from the website. By the way, we removed one company because some of you work at the company. So it's missing here. I'm not going to mention who it is. But it was actually already here coincidentally, which is fascinating. But it was a long time ago, so don't worry about it right now. It's not relevant. Your company did not implode. You're fine. What the percentage is, it's the data score that led to the lead up of the problem. You can see Enron had the highest negative score. This is the percent for indexing against where they should have been at 0% or positive, that the larger the negative number, the more likely it was predictable. And at negative 32%, again, you have to compare that to benchmarks. That was really large. Also, you could see that this was happening well before. Again, you won't be able to understand the percentages until you actually go to the website and look at the formatting. I wanted to keep a clean slide without lots of text, but you can read that commentary. Just using FTX as an example, you can do this as humans without necessarily using AI or deception technology. A friend of mine is a venture capitalist at Andreessen Horowitz, very well-known venture capitalist, was approached about investing in FTX, and he declined. And he gave them some really useful feedback. He said, go get a board. This is a financial services, financial transaction company moving money at the scale they were, but you're talking about fiat currency or you're talking about any cryptocurrency, and there's no board of directors. So, and then forget compliance. You guys have probably read about the challenges there. Some of this stuff is predictable, but sometimes it's not. Sometimes you just have to read between the lines, and you could do it maybe on one statement in a 10K. that, oh yeah, this seems like it's a little bit of marketing fluff in how they're describing this new venture or new initiative, or they're putting lipstick on the pig with these metrics. Maybe you could do it in isolation, but our brains aren't able to process it over 50 and 60 and 70 page 10Ks quarter by quarter over 10 years. And then marry that to the earnings statements, and then suddenly you can find the linkages in deception. That's incredibly powerful. So you can imagine this kind of technology becomes table stakes and hygiene for any investor relations department in a public company. That before you put out your 10K, before you put out your 10Qs, before you put out earnings reports, you're running it through data and making sure you don't make deceptive statements. In fact, my own quarterly reports for my venture capital fund, I ran through data to check. Turns out I was at 99% positive. No deceptive statements, as high as you can get, 99%. I didn't bake that. Like, I literally just wanted to see myself, and they offered to run it for me. It's incredibly powerful what AI can unlock when you start thinking about the use cases. I mean, I just gave you two radically different use cases. We're going to talk about more about the power of this. Now, in theory, if you didn't have this as hygiene, this company data could just say, well, we're able to predict the future. We can tell you right now, just based on deception. At least predict catastrophic risk, which if you look at, even if you hold a basket of positions in public equities, and I'm just using equity markets, I'm not even talking about the bond market. If you look at what the returns look like, you'll find that you'll see massive drops in returns when you have an accounting scandal or a blow up where the value goes effectively to zero and you can't liquidate, or you're liquidating in a falling knife situation. If you could eliminate any of those from your portfolio, suddenly what does the return look like over a long period of time? It's dramatically better, right? You might have had a good return the year Enron dropped, but it might have been dramatically better without Enron in that portfolio, right? So this is powerful, but I think if they were just trying to ingratiate themselves with money, they could just take the technology, raise a large hedge fund, and just invest where they have no deception. That might work as well. So you can start thinking about the use cases. This one is just an interesting one to talk about because deception can be used for a lot of things. In this case, we're simply talking about money. It affects shareholders, but it does affect employees and people's lives there as well. Let's talk about decoding human emotion. This is Monet Analytics. These, I don't know if you can read this, these are different emotions. And there's a scale where Monet can evaluate somebody in real time in their video content and be able to determine exactly what the audience is feeling when they watch that content. Essentially, I can watch you watch content. You can imagine this is for predicting if a movie's going to do well. You can look at content creation. It's really powerful for focus groups, right? It would fundamentally change primary research. If you start thinking about primary research, qualitative interviews for the research industry, for PhD students and faculty, and you start thinking about interviewing somebody to be able to detect not deception, but rather their emotional roller coaster, you can start to predict what's going to happen. And there's huge implications for that. The research industry really hasn't been unearthed in a long time. So we were able to detect this, but we ran this on political candidates. We can watch their speeches and see how audiences are reacting. We can also see how the speaker is reacting, what emotions they're experiencing. So you could essentially take persuadables and determine how they're feeling about a given speech and a given issue at any given moment in time, because you can read the nonverbal cues on their face. This is decoding human emotion. And you could figure out what issues matter. And I'm picking deliberately a presidential election because you could figure out if something matters to people or not. You know, maybe we don't want to talk about immigration, but it turns out that's an emotional hot button based on how audiences in given states might react to that issue. And so maybe you need to talk about it, or maybe your position is not reflective of the general constituency you're going after. It's a really powerful tool. This is called Monet Analytics, using deep learning and AI to predict and to evaluate and decode human emotion. If this could be done in large scale, I mean, the implications are profound and pretty scary. It would kind of fundamentally change everything we do. Imagine being on a Zoom call and there's like an emotional reaction, reading your nonverbal cues, facial expressions, everything you're doing. You can't control that. You could try to look sad, but maybe it says you're happy or vice versa. There are times when you might want to hide your emotion and you can't. You're in an interview and you're being evaluated for something. You're in a performance review, you're being evaluated for something. And you're thanking the interviewer for doing a great job when you think the interview was terrible and they asked you dumb questions. Or vice versa at a performance review. You can think about if these types of augmenting technologies are decoding human emotion, the use cases can get really scary. So we talk about AI and Skynet and things like that, but just the mundane, regular use cases can have real implications for our behavior. And we need to think about the abuse of these types of technologies. This is one where I think it can be abused, and we're really careful to make sure the use cases are very constrained in what we're offering to prospective customers. So our double-blind introduction model. So let's talk about Tinder. Most AIs that develop, there's fundamental training data that supports it. We certainly have that in the dating space. But I would encourage you in your companies, when you start thinking about the application of AI, take a white piece of paper, a green field, and start fresh about what you're trying to accomplish, okay? And let me use the analogy of how we invented Tinder to give you an analogy of thinking through first principles thinking, which I'm sure many of you do anyway. Elon Musk talks about it all the time, but this is like foundational. I'm a chemical engineer. I have very first principles thinking in what I'm doing. I'm getting my PhD at Stanford right now. This is like core to everything we approach. You could apply it to AI, you could apply it more broadly. So roll the clock back to 2012, about 14 years ago. If you were going to build a dating business, you'd be building something that would compete with Match.com and eHarmony. Okay, those were the two largest players. There were a few other dating companies. The stigma of online dating had sort of started to dissipate, hadn't dissipated as much as it has today. I think today it's kind of going the other way because people are trying to meet offline more. So the use case, if you were to use the existing products in the market, they would have probably led you to believe, especially if you hadn't done focus groups with nonverbal cues and decoding human emotion, probably led you to believe that you need to figure out a way to shorten creating a user profile. Back then, if you created an eHarmony or Match.com profile, it took hours. You had to upload pictures, sometimes move them from your computer to your laptop. You had to write a bio intro. I mean, the bio itself would have taken 2 hours. There was no ChatGPT to do that. It was a pain. Okay, so if you were saying like a classic entrepreneur, how do I fix dating? You would have gone into a venture capitalist's office and said, you know what, have you ever created a Match profile? And let's say the VC said yes. Say, oh, you're familiar with these problems. It takes this long to do this. It's a real pain. We've solved all of that. And they would have said, oh, great, yeah, it makes sense what you're offering. And you've done it cleverly, and we believe maybe you could drive some product marketing around it, and so you could build a big dating business. But that would have been the wrong problem to solve. It's a false signal. The problem with dating was so much more fundamental and core. And it gets to behavioral economics. It gets to payoffs in psychology. We get to primal human behavior. And let me expound on this and explain how we developed it at Tinder, and I'll walk you through an example, and then we'll apply it to AI. So I walk into a bar or restaurant, and I see someone at the bar, and I want to go have a conversation with that person. What's holding me back? Why don't I go talk to that person?
Fear of rejection.
Fear of rejection, exactly. So let me now take fear of rejection in layman's terms and sort of make it a little more scientific. In behavioral economics, borrowed from psychology, it's really loss aversion. I have an aversion to loss, and omission bias. An act not seen is better than putting myself out there and essentially failing, okay? And by the way, there's a great read in HBR about this. The CEO of Domino's Pizza talks about this with cultural change. I think this is very applicable to how you should think about AI impacting the organization, omission bias and loss aversion, and how he took Domino's Pizza from what it was worth to being worth a food company, being worth 10x after he came on board with his implemented changes. That HBR article is fantastic on Domino's Pizza. So it's these two things holding you back are these psychology principles around our human behavior. And as a chemical engineer, I think of it a little bit differently. If I had a whiteboard, I'd draw it for you, but essentially it's this big hump. You're over here and you want to get over here, and there's this big hump in front of you. That's your activation energy you have to traverse. And I want to bring that activation energy down to 0 to get from point A to point B. How do I do that? Well, in the case of this example of wanting to talk to somebody, I essentially want someone to tell me that they're interested in me, and I want to express interest in them, like have their friend whisper in my ear and I'll whisper back, but only let them know if I know they're also interested in me. Otherwise, I have fear of rejection. But if they're not going to find out if I express interest, we're all good. So it's a double-blind introduction model. Well, guess what? Do you think you could do that programmatically? Yeah, you could do that programmatically. And by the way, do you think it scales well if you could do it programmatically? Yeah, it scales really well with technology. So we invented the double-blind introduction model. We did not do a focus group, even though I used Match.com and others, and see what other products are out there. We fundamentally started with understanding human behavior at a first principles level and designing technology to address it. And I want you to take that analogy and think about it when you develop AI. When you incorporate AI into your organization, if you're developing foundational models, but most of you I think are using existing models, think about what you want to achieve very carefully and design it from first principles. Don't just think about incrementalism when you're applying AI, because you might be solving the wrong problem. The swipe was not the innovation of Tinder. The swipe is a manifestation of the double-blind introduction model of making a binary choice, yes or no. Candidly, had we not, if you look at the product insight, and I have a blog about this called Human Product Management, we would have probably been about 90% of the size of what Tinder achieved just on a yes or no button. The swipe was fun and it was clever, so people adopted it and people talked about it, so it picked up some PR, and I'm saying that's like the 10% increment. But the fundamental reason people were using Tinder, if you understand what's happening inside their brain and in their heart, it's they're not taking risk. And that had nothing to do with the swipe. By the way, the swipe, the code for that existed before. We had access to that code because our engineers, by the way, the guy who actually implemented it was like an actor in Hollywood. He was my front-end engineer, Jonathan Badin, really smart guy. That swipe capability existed in other apps, just wasn't widely adopted. This was a perfect use case because it was a binary choice left or right, and it was a natural ergonomic use case within someone holding a smartphone. So I wouldn't use that as the analogy. I would say that was useful, but not necessarily the insight behind Tinder. So I guess I'd encourage you, because I'm going to treat this as homework, go back and think about it. What's going to fundamentally change with social discovery and AI? There's the obvious with bots and other concerns. Remember, we talked about the Black Mirror effect, the abuse of technology. This is a big area where technology might be abused. And then, do you think it's really going to get better as a result of this? Do we need more of this to build a better society, to make more money? I get the impression we want to meet offline. In fact, I think there's a big movement in the dating space, and why the market cap, a lot of these companies have peaked and in some cases dropped. I think Bumble's down like 95%. Tinder's down a little bit. It reached a peak market cap of Match Group at 45 billion in 2021. It's down a little bit from there, but a lot of these products are having trouble acquiring new users because modern generations are reluctant to go through this contrived sort of experience. And so there's other fundamental questions for society as a result of some of these challenges. So you can imagine every industry is really going to be affected by this. You guys may have seen a version of this slide before. I've seen versions sort of on the internet. This is the one that I had developed when I was an operating partner as an exec in residence at Warburg Pincus. But essentially, you have all these industries that are fundamentally gone and radically changed as a result of insurgence. And the AI insurgency is going to accelerate the pace of that disruption, obviously. But it's also changing what's possible. There are things that just were not possible. And I use the example of addressing the disease of Alzheimer's under the current trajectory. And with AI, you can do things now to actually halt Alzheimer's. I mean, that is amazing. So 2 more things I want to leave you with. 1, this is all going to be messy. We're in the messy period. We're in the embryonic stages of it being really messy. And you have to get a little comfortable with that. So I know that we didn't get into talking about Tesla and how Tesla is applying AI to all of the proprietary data it's collecting. But I like this slide because it really gets into a view of maybe the robots being a little more sentient. So I guess what I'd leave you with is talking about goals when you're bringing this into your company. Is the goal to train better models to improve AI? Seeing head nods, yes. I would argue no. I think that's one component of it. That's not the goal. I think the goal is for AI to improve the human condition. And therefore, we need to think very carefully with first principles analysis. What is the goal of what you're doing? When you think about the project you're working on that's going to employ AI, and you start working on it, and let's say you get to an end state where it's successful for you in your business unit or in your company, and you get a big bonus and everything looks great, and you put it on your resume and you work on your next thing, what are the downstream second and third order implications of what you just did? Who's going to build on your work? What's going to happen? Did you put in guardrails? And did you achieve your goal, or did you just create more complexity for your users, because now they're dealing with some chatbot with AI and they still have to make the phone call. So think very hard about the constraints of the problem and the design of the problem. And maybe I could make one more adjustment to this. Maybe it's to improve the sentient condition if we start to think about what's possible with AI.